Okay, thank you for inviting me to present at this webinar. My name is Ina Ekeberg. I'm head of customer development at Alma Clean Power, and I'm gonna present how we aim to accelerate the transition to a net zero ocean space using flexible fuel cells. So I will start the presentation by telling a bit about who Alma is, where we come from, and what our ambitions are. And then I'll talk a bit about the technology and why we believe that this is important to bring forward. And then I'll talk a bit about our projects and our roadmap going forward. So all of you might not know Alma yet, but I think many people in the, say, energy sphere in Bergen probably know CMR Prototech. CMR Prototech has a long history with research, development, and prototyping of energy systems and particularly fuel cell systems. So I'm not going to go through the whole list of highlights from the Prototech era, but I'm going to jump to 2021 when Aker bought Prototech. So at this time, Prototech changed the name to Clara Venture Labs, and Alma was established as a separate company set out to industrialize and commercialize the solid oxide fuel cell technology that had been developed in Prototech for more than 3 decades. So today we are a team of 36 people working hard every day to bring this technology to the market. So we've had a look at the history already. So I want to focus on the future and our ambitions. So if you in 2024, next year, we will have our first solid oxide fuel cell system tested on board a vessel. I'll come back to that later. In 2025, we aim to have the first commercial product available for the market. And in 2026, we aim to have a large-scale factory built in the Bergen area. So as I already mentioned, we're owned by Aker. And being part of the Aker ecosystem is valuable to us in many aspects. And I can just mention that we collaborate closely with Aker Solutions, and our fuel cell modules are now being assembled at Aker Solutions site at Ågotnes. We are also we're very proud of our customers, some of which you can see on the middle left box here. Sorry, let me right. I will talk a bit about these projects and our partners later. And I also want to mention our alliance partners, because we really appreciate the close collaboration we have with the clusters and partners in the region. I can mention particularly Sustainable Energy Catapult Center, which have the energy house at Stord, where we are. Alma is one of the 4 partners in this this energy house, which is a test center set up to test different types of clean technologies. And this is where we will test our fuel cell systems. Now, solid oxide fuel cells can be applied for many applications in many industries. And our focus at least for the first years, is on maritime shipping and offshore oil and gas. In maritime shipping, it's particularly the deep sea shipping segment, where batteries and hydrogen fuel cells alone are not sufficient. And it's actually 90% of the fleet, batteries and hydrogen will not be sufficient. So this is where we are focusing and have a solution that we believe is very relevant for this segment. And we know that rules and regulations are progressing, and IMO recently increased their ambitions, which is now net zero by 2050. So there's lots of things happening within the shipping industry to say force a transition in the whole industry. And the oil and gas industry is also transitioning. I will say there are large variations within this industry, but many of the international majors are really pushing new energy and low carbon solutions. So with solid oxide fuel cells, offshore installations can be decarbonized without power from shore. And well, I think this is quite interesting when considering the energy situation and the grid challenges we have in our region particularly. When it comes to decarbonizing shipping, there are two keys. And the first is to increase the energy efficiency. And this is always the first step to decarbonize whichever application, right? It's the cleanest energy is the one you don't use and the one you don't have to produce and transport, etc. So energy efficiency is extremely important. And in addition, it is also inherently cost efficient, right? So it's a win-win for the user and for the environment. And the second key is to reduce the carbon intensity of the energy that is used. And this can be done either by low or zero emission fuels or by carbon capture. So our solution to this is a power system which is based on solid oxide fuel cells. And an example is shown here, a containerized solution which can operate on ammonia, fuel in, power out, and which we received approval in principle for earlier this year. The reason why we selected solid oxide fuel cells is that it solves the two main challenges related to decarbonization, namely that of it has significantly higher energy efficiency than the alternatives. It has about twice the efficiency of an offshore gas turbine, which means that you can cut both fuel cost and emission in half by the efficiency alone. So that's extremely important. And secondly, it can be used with both existing and future fuels. So it can operate on hydrogen as any fuel cell, but it can also release hydrogen from other constellations, such as natural gas or methane, as shown here, or methanol or ammonia. And this is what makes it a deep sea solution, because in deep sea, you need fuels with high energy density, like LNG, methanol, and ammonia. And for oil and gas, well, natural gas is the most relevant fuel, right? Because that allows offshore installations to be self-supplied with power, while significantly cutting or potentially also eliminating emissions. Yes, there are multiple other benefits. One is the high carbon capture potential, which I will come back to. Because yeah, when operating on carbon-based fuels like natural gas and methanol, CO2 will be part of the exhaust, and there are quite efficient way of capturing the CO2. And because fuel cells it doesn't have rotating or moving parts. It's typically has lower maintenance and is less vibrations and noise related to it. I'll give a brief description of the fundamentals of solid oxide fuel cells. It's the fuel cell produces electricity by an electrochemical reaction, and it consists of a solid electrolyte and an anode and a cathode. Fuel is supplied to the anode side, and air is supplied to the cathode side of the fuel cell. Oxygen from the air is transported through the electrolyte, and this will combine with hydrogen and form water, which will be the exhaust on the fuel side. While on the air side, the exhaust will be air with a reduced fraction of oxygen. And I mentioned that SOFC can also use other fuels. So if we consider methane, methane can be let into the fuel cell, and in the fuel cell, a steam methane. A steam methane reforming process will occur in the fuel cell, releasing the hydrogen, and in that case, CO2 will be part of the byproduct from the fuel exhaust. When we say that it's easy to capture CO2 from a process like this, it is because, unlike combustion processes, the CO2 is not mixed with air. So to illustrate this, we set up this diagram showing typical exhaust compositions from different gas to power processes. So you can see it's a significantly larger volume of exhaust that needs to be treated when power is generated from a gas turbine or from a gas engine. So that makes that means that we can go with a smaller and more cost and energy efficient carbon capture system when capturing the CO2 from the SOFC system. And I'm not gonna go into detail or say much about the carbon capture process, because we are collaborating with the suppliers of different CO2 capture technologies, and well, it's we hope to find out which is the best solution for a combination of SOFC and carbon capture. So then I'll talk a bit about what we do now and what we are planning to do for the next 2 years. So we are currently in the pilot and demonstration phase. We have, I'm going to mention 4 of our ongoing projects here. We have the Clean Ammonia Power, or CAP as we call it. This is a 100 kilowatt direct ammonia fuel cell system, which will be tested at Energy House at Stord early next year. And we have already tested a scaled version of this one earlier this year, a 6 kilowatt system, which showed very good results and very high efficiency. I think we had efficiency up to 67% when testing this fuel cell. And this is a project we're doing together with Equinor, Ekeberg, and Yara. Another project is the KOP CC project, and KOP, that's short for Clean, Highly Efficient Offshore Power with Carbon Capture. And this is a SOFC system for natural gas with carbon capture. And we're now building a 80 kilowatt pilot installation, which will be tested at Energy House as well next year. And this system will also be tested on board an Odfjell tanker vessel, also end of next year. So it's the KOP project is a collaboration between Alma, Odfjell, Ekeberg, Wärtsilä, and it's supported by Gassnova. The Helenus project is a EU-funded project which aims to demonstrate SOFC on LNG. It will be delivered to the shipyard Chantiers de l'Atlantique in 2025, and it will be installed at an MSC cruise vessel. And then last but not least, the SHIP FC project. The SHIP FC is also a EU-funded project where we are building a 2 megawatt ammonia fuel cell system, which will be installed at Ekeberg's Viking Energy ship. This is a collaboration also with Equinor and Wärtsilä, and Maritime Clean Tech is also is a project manager for the whole project. It's a large project which consists of, I believe, 14 partners around in Europe. So with these projects we have ongoing now, we will be able to pilot and demonstrate and take this technology from the TRL level 4, which we're at now, until 7 when we take the first fuel cell on board a ship, and continuing to TRL 8 and 9 when it's installed and in operation and on the vessels. So that was what I had prepared for today. Thank you very much for the attention. I hope we can have some more good discussions as we had in the beginning, and I'm of course open for questions. And also, I just if you want more details, or if you want to discuss anything in particular, then please reach out to me.